Okay, let's talk specifically about the drive train and how we generate or how we take a force that's applied here at the pedal that ultimately ends up down here at the rear wheel pushing the bike forward. Remember, from our kinetic analysis, the propulsion force is pushing on the wheel in the direction of movement. So we push on the pedal here. This is a crank arm right here. That force generates a torque about the axis of rotation, which is the bottom bracket. That torque rotates this the front chain ring, and as that rotates, there's a pulling force generated on the chain. And in a separate lecture, we'll go through the mechanics of that, talking about the torque generated by the force on the pedal, as well as a resisting torque due to the chain pulling on the chain ring. But for now, we're going to say there's a pulling force generated on the chain. That chain pulls on the rear cassette, the rear cog. That generates a torque around the hub axis of rotation, and we can figure out that torque by knowing that moment arm. That torque wants to rotate the wheel in this direction, clockwise, and as that wheel tries to rotate, it interacts with the ground, and friction prevents that wheel from rotating, and there's a force that's resulting from that pushing on the wheel to move the bike forward. So if I push on the pedal, the bike obviously is going to move forward because of that force down there acting at the bottom of the wheel, pushing on the bike in that direction. And that's because there's friction between the tire and the ground. If I make this surface super slippery and I push on the pedal, all that will happen is this wheel will spin in place. For example, if we're on ice, or if I go over here, I do the same thing, I push on this pedal, obviously there's no propulsion force because the wheel is not in contact with the ground at all. Oops, I'm going the wrong way. So the wheel is just spinning, okay? If I put this wheel down in contact with the ground, there'll be a force of the wheel pushing on the ground, and the ground was pushed back on the wheel, equal and opposite, Newton's third law, to generate the propulsion force. Okay, so that's our drive train, and there will be another video showing some of the math behind pushing on the pedal and generate the propulsion force, and then considering how big this chain ring is here and how big the rear cog is. Those things will all come into play with understanding the propulsion force and how much I need to push on the pedal to ultimately generate propulsion force. Okay, thanks.